In this video, we are going to discuss about the interfacing sensor and wireless module. By the end of this topic, the students will be able to describe how this multiple specialized biomedical sensors or hardware interfaced with the microcontroller, and they can able to analyze the data pathways within the integrated patient monitoring system. They can able to evaluate the conditioning steps for transforming the real-time responses to digital information. So, to introduce our topic, modern biomedical systems actually rely completely on the integration of multiple hardware sensors with high performance microcontroller. Actually, this structural blending is what it makes real time continuous patient monitoring very possible. So, this capability is very high amount, and it bridges the gap between the passive diagnostics and the proactive life-saving clinical interventions by giving doctors a constant stream of live physiological data. And here the data moves through the hardware by examining the data acquisition or DAS. This clinical DAS operates as an electronic pipeline that systematically collects conditions, converts and processes the physiological signals. And in the biomedical sensors, this measures the target physiological modulates like temperature, ECG, pressure and oxygen saturation. At the very front of our signal, we can see the specialized transducer that is interfaced with the human body, which is used for measuring the vital signs like temperature, cardiac electrical activity through the ECG, arterial blood pressure and blood oxygen saturation level through this pulse oximetry. And next is the signal conditioning. Once the raw electrical signal leaves the sensor, they must pass through the signal conditioning stage. So, this will be mostly weak and heavily absorbed by the environmental noises. So, this stage utilizes the precision instrument amplifiers to boost the signal amplitudes along with the bandpass filters for removing the movement artifacts and also the power line interferences. Purifying this signal only increases the data quality, and also it is ensured through the clean, accurate representation. Next, it is given to the microcontroller. So, this microcontroller is the heart of the embedded architecture. So, this functions as the central commander of the patient monitor. This uses the internal analog to digital converter to digitize the condition sensor waveforms. Then it is given to the wireless communication protocols. So, here depending on the specific clinical environment, we can deploy the Bluetooth or a BLE for low power wearable body area networks, even Wi-Fi for high throughput institutional LAN tracking, Zigbee for robust mesh based word monitoring, and GSM for long range mobile telemetries. And the applications, these integrated technologies are deployed in the real world. Actually, interfaced sensor and wireless networks are the major things used in the modern telemedicine platforms. And by taking this data acquisition completely wireless, we can improve the patient mobility and also comfortness by providing continuous reliable system of automated diagnosis, that is automated diagnostic data straight to the clinical workstations. Thank you.